All right, guys, so just a little bit today here. I forgot to say this, but anytime we create a graph by hand, coming off of work we've done, the graph must match the work. If the graph somehow magically matches what it's supposed to be, but your work says something else entirely, you will miss a lot more points. But if your graph is wrong, but it matches what your work says should be happening, you might not lose any points for the graph. You'll just lose some points for the work you did. Do you understand? I'd much rather you, because the important part there is, can you do the work in the first place, and then can you translate it to the visual? That's what I'm checking. So if the visual is coming from somewhere else and not your work, I can't grade you on that. You lost points on that. You didn't show me you could do it. Do you understand? So if it says concave down and you do concave up and it's supposed to be up, I'm like, no, it should have been concave down. You should do what your work says. All right? Okay. My pre-calc students, you remember that. I said the same thing to you when we were graphing stuff. So the last section in chapter 4 we haven't done yet. And it's perfect because it leads right into chapter 5. So the next big idea. So we've talked about derivatives. We totally understand derivatives. We talked about several different applications of derivatives, and we sort of understand some of that. So now we're going to talk about the reverse of it. Because math, you've always got to be able to go both ways, right? So we have to take up to like differential equations. You guys know diffie-q is what we call it. Diffie-q is equations with derivatives in it. So it's not quite. It's like related rates just on crack, right? It's like you can have second and third derivatives inside of it. So you have to understand the opposite of a function to be able to solve an equation that has that function in it. So obviously the next thing we want to do is, if I can take a derivative of f, I want to be able to undo that derivative and work my way back to what f was. Okay, so that's the next big step. And I think I put like a bonus question or something one time, and the basic idea is pretty simple. The more you understand derivatives, the easier some antiderivatives will be. So we'll come up with a better name for it, but right now we'll call them antiderivatives. Derivatives. So for example, and normally what we do is we'll say, given f of x, and I think I told you this before, big ass f of x is the antiderivative, and that's just the standard notation. You could use this notation, it doesn't really matter, but in the theorems that we talk about, they'll be using that big ass f notation. Right? Given f of x is the antiderivative. So, for example, some really basic examples. If f of x is 3x squared plus 2, what might f of x be? Big ass f of x.
X cubed plus 2. X cubed plus 2x plus c.
Ooh, look at people that are head counting. Okay. So you got to start thinking backwards, obviously. Where would 3x squared have come from? It would have come from x cubed, I like it. Where would 2 have come from? Are you guys 2x, it would have been 2x, because I can see the derivative, so what would it be here before I take a derivative? 2x. And of course, there's a plus 0 here, so it doesn't matter, any constant could have been there. So that's a huge thing. So anytime we're doing these antiderivatives, you basically just keep tacking a plus c at the end to cover your ass for the fact that there's a plus 0 for any function. So what would that be as an antiderivative? Some constant. Right? I like it. So part of the study we do for antiderivatives is what kind of problems will allow me to figure out exactly what that is. And let's think about this. Why does this make sense? Graphically, why does it make sense? If I'm given some function that represents the slope, the one thing, so if I'm given this function, this is the slope of my function, right? Let's say that's the slope of my function. Then my actual function, this just tells me what my function looks like. It doesn't say where it is. So the slope here, for example, let's say, well, the slope here, for example, has to be 0. It has to be flat there. But it doesn't say where. So it could be here or there, as long as it's flat there, right? And of course, it would be the other way around if you want to get all technical, because here the slope is
Positive.
negative.
Yeah.
So be careful. So I really want you to understand, because part of the homework, you're going to love this, because you loved it before. Part of the homework is they're going to give you f prime. You have to sketch f, big ass f. Right? Yes, sir.
So if you have a point, does it help you find a lot of the C's?
All I need is a single point that would be on f, and then I can figure out what c is, right?
Okay. Question for that, because we also have like cosine and sine. Couldn't that one get weird? Because if you move it over enough, C doesn't really, or the point you give us doesn't really matter, because if you moved it over enough, it would still show up.
Oh, you're worried about, cosine and sine have their own arbitrariness to them. The phase shift and stuff. That doesn't factor in here. I'm just talking about the up and down. I mean, this is a y-intercept idea, right? So that doesn't really factor in. This would be just the y-intercept of it, right? So a sine is going to look like a sine, but just I don't know where it is on the coordinate system without information. Okay, but if this is the slope function, then here the slope is negative, so it must be going down. Here the slope is 0, so it must be flat. Here the slope is positive, so it must be going up. So right around here it's negative, flat, positive, right? So it looks something like that. And then here it's got to be flat again, right? And all through here it's got to be negative. So the next place it's flat is going to be like right here. It's flat. And then the slope is positive, right? I'm kind of going backwards, but so the slope is positive here. Then it's flat there, a little bit off, but hopefully flat here. Then it's negative slope all the way till here, and then it's flat, and then it's positive slope after that. All right. And why does this make sense? What did we just do? We just had an x squared. We had a parabola, and sure enough, when we got big ass f, it was a cubic, which is what this would be, right? So, of course, that whole idea of the degree changing by 1 works here also, just the opposite direction.
You said it could be either height of and the positive.
Yeah, so the thing I don't know is, I'm assuming that these winders were here. That whole picture, I could have drawn this whole picture here, and it would have still been true. Do you guys see that? Because just knowing the slope will tell me what the function looks like. It won't tell me where the hell the function is.
How do you find that?
I have to be given more information. So if I told you, find f given the derivative and also that f of 1 equals 7, well, then I just plug a 1 in and force it equal to 7, you can figure out what c is, right? This is what's called an initial condition. Initial condition. Okay, I like it. Cool. I can live with that. We got some more time. Good. So let's try to do one general antiderivative formula. I don't even know if I'm following what the book says, but too bad for the book. Recall, if I have x to the n, its derivative, of course, is n, x, n minus 1, or one of our most favorite rules, right? So you should probably figure it out, but just to show you. So if I have f of x equal to, so we just did this one right here, right? That was pretty simple. You can probably figure out the rule there. But let me give you something that's a little more interesting. So what if I had this 5x to the 7th? What would big ass f be? So I'm taking a what?
Antiderivative.
Antiderivative. I like it.
5x to the 8. 8.
I like it. So add 1 to the 7.
Divide 5.
And then go ahead and divide the 5.
Divide
So 5 over 7.
by 7.
5 over 8.
By 8.
Put it again.
So why does that work? Because, and let me just replace that with 8 so everybody sees that's the rule. Because whatever, if this is going to come down, is the 8 here?
No.
If I take a derivative, it's supposed to work. So if that comes down as an 8, I better have an over 8 to kill it because I don't want it to be there. That's going to happen so much. In fact, let's make it happen right now. Watch this. That's kind of cool. Let me see if you guys can get this. Obviously, and I know we'll get there, don't worry. Hopefully it's obvious that this guy is remarkably nice. Because this, and of course, what did I leave out?
Plus C.
Yeah, I'll make a big point of that. So what would this be?
B to X plus C.
Alright, so what if I had this?
It'll be 1/3 E.
I like it. So it's itself, but if I took a derivative, what would come out? A 3. So I better have an over 3 to kill the 3 that wants to come out. I know I teach violent math, right? But that's a really important idea to get down now. It'll make it so much easier later. We will learn a kind of a useful process for when things get more complicated, because it's not very complicated right now. But the more you understand why that over 3 is there now, the easier that other method is going to be to see why it works. Some of you guys know where I'm going with that, but we're not there yet, so it's not. So what would a general? So this is just me going crazy. What would be a general rule then for the antiderivative of x to the n? Thinking about it like that.
Increase your power by.
So if I have this. So go ahead now. Sorry.
Xn plus 1 over n plus 1. Let's see.
Right? Because if you took this derivative, what would happen? The n plus 1 would come down, cancel, and that would go down to n, and of course the derivative of constant is. So that checks. If you check it, it works. It actually checks out. So that's our first little baby antiderivative rule, which makes sense because the first derivative rule we learned was that one. We might as well unlearn that, or learn the opposite. Let's not say unlearn. Don't unlearn. It's a bad direction to go in. Okay, that's plenty for today, I think. So next time we'll officially get into, we already did get into chapter 5 a little bit, to be honest. We'll get into chapter 5 next time.
I think that stand on that test was